Hi guys, Professor Latimer here, the CC mom who loves science, and today I want to bring you hands-on science experiments for week 18, cycle 1. And we've got 2 experiments today. They are number 140 in your Van Cleves, which is on page 77. It's called Push Up. And then we have number 142 in the Van Cleves, and that is on page 78, and that's called Updraft. So I'll show you the push-up experiment first. And the supplies for this one are really easy. You just need a large bowl filled about 3/4 of the way with water, and you'll need a small clear glass. And for your bowl, you can have a clear bowl. That might be kind of nice because you could see the water levels changing easier, or you could just have the students gather around. But you want to make sure that you have a clear glass so you can see what's happening on the inside. So your bowl needs to be big enough and fill and deep enough with water that your glass can fit in and be fully submerged in the water. I have Nicole Liam's science scripts for this week here. She has some really great questions and talking points to mention. So I get these from CC Connected, and that really helps me. So what we're learning about today is atmospheric pressure. And so you can ask them about air. Can you see air? Can you feel air? Can you smell air? How do you know that we have air around us? And kind of get their feedback and kind of what they know about air. And then we're going to learn about, ask them, do you know what atmospheric pressure is? And if they do, or if they don't. So ask, what is air made out of? And air is made out of all these tiny, tiny molecules. And by themselves, they don't weigh very much. But we learned in the layers of the geosphere, we have an atmosphere, and that's filled with all kinds of air molecules and gases that make up our air. And there's another force that we have on Earth called gravity, and that pulls things onto the Earth so they don't float away. So it helps us stick to the Earth, and it also helps our air molecules not float away into space. So gravity is actually strong enough to pull those tiny air molecules closer to the surface of the Earth so they don't float away. So our atmosphere is really, really thick. And so the gravity pulling down, it condenses all those air molecules. So when you're close to the surface of the Earth, the atmosphere is a lot heavier and denser. So when you're at sea level, like when you're, say, at the ocean, you're at the beach, that is where the atmospheric pressure will be the heaviest because you're the closest to sea level. That's where the air molecules will be densest. Your atmospheric pressure will be highest there. If you climbed a mountain, the air is lighter up there. There's not quite as many air molecules packed in when you're up on top of a mountain. So it might actually be, if you're used to sea level and you climbed a high mountain, it might be harder to breathe because you're not getting as many air molecules as you're used to. So there's a pressure. It's like the weight of all those air molecules. And so at sea level, it's 14.7 pounds per square inch. That's the weight, that's the pressure that we have. So we're going to test, is the weight of the air, the atmospheric pressure, is that, can that push harder than water? So you can get their hypothesis. So what you're going to do, this will be tutor demonstration, and you'll have your bowl full, 3/4 full of water, and you'll have your cup. So you ask them, okay, what's this cup full of right now? And then it's like, is it empty? Is it really empty? Or no, it's full of air. And so what we're going to do is we're going to get this cup completely full of water. So I'm going to tilt the camera. There we go. Okay. So you're going to submerge the glass we're going to at an angle, and you're going to kind of tilt it to see if you can get all the air bubbles out. So it's completely underwater. Then you're going to turn it upside down. Okay? So your glass, so you can ask them, come observe, is there any air left in the glass? And there shouldn't be. And it's full of water. So you're going to ask their hypothesis. What's going to happen when I try to lift the glass out of the water? Is all the water going to run out of the cup? Is it going to fill back up with air? What's going to happen? Is it going to be easy or hard to pull the glass out? So kind of get their hypothesis, and then have them, as you pull the glass up, have them observe the level of the water and see if that changes as well. So you're not going to lift it all the way out of the water. You want to leave it, the edge of the glass still in the water, so no air can get in. But you're going to lift it up, and if you can tell, the level of the water is going down. So you can ask them, okay, is the glass still filled with water? And it is. So the water didn't rush out. And why? Because gravity's pulling on that water in the glass. So the gravity's pulling down on the water. But you also have the pressure from the atmosphere. It's pushing on the surface of the water here. And you can think about like a straw. When the like liquid comes up a straw, because where the atmosphere around it can push it up. That's kind of what's happening here. So the atmospheric pressure is pushing down so much that it's actually pushing the water up into the cup. It's not letting it come out. So that means that this atmospheric pressure can support the weight of the water. So this means that the water inside this glass is actually lighter than the atmospheric pressure. So that's pretty cool. I saw this experiment done like where you can get 2 glasses of water and 2 glasses and put in here at the same time and lift them both up and see if the atmospheric pressure can support that. So that's just a fun way to kind of get an idea. Okay, there's pressure from the air around us, and there's some vocabulary you can use. You can talk about what a barometer is, and that's what the weathermen use to measure the atmospheric pressure. And when there's a change in the atmospheric pressure, then that usually means that the weather is changing. So scientists and meteorologists measure the atmospheric pressure to know what the weather is going to be. So that is the first experiment. And I'm going to switch this over, and then I'll go to the next experiment. And that would be number 142, which is updraft. So for this experiment, this will probably also be a tutor demonstration. And this is when you might want to practice at home. I had pretty good luck with it working, but you might want to practice it just to see if it works, with your lamp. So for this experiment, you will need some tissue paper, piece of tissue paper. You'll need scissors. We're going to be cutting out a spiral from the tissue paper. So I did it. I drew it on the tissue paper before I cut it. So Van Cleef's guide kind of has a diagram of what you kind of want to cut out. So I just kind of roughly followed that and drew it out, and then I cut it out. And then you'll also need some thread and a small piece of tape. And you'll need a lamp, like a desk lamp, or this is just like a little bedside lamp. But you'll need a non-LED bulb, like just the old kind of incandescent light bulbs that get really warm. But LED ones won't work because they don't get hot. And that's what we're going to be testing today. If you don't have a lamp with that kind of bulb, I also have seen this experiment used with a little tea light candle and put it in like a glass jar. This jar is probably a little too big, but there's kind of taller, skinny ones. And you'll just light the candle and put it in the jar, and then that will create the heat, and you'll hang your spiral above that. So you can check with your campus and your director on if that's a possibility. But I've also seen that work as well. But I've had, it's been working with my light bulb here. So I'm gonna go ahead and turn it on so it can warm up. But it doesn't take very long to heat up. So you can cut out your spiral ahead of time. I might recommend doing that. It's kind of fiddly to cut out a spiral onto tissue paper, but it might save time. Or if you have littler ones, they might get kind of fidgety waiting for you to cut it out. But I cut out 2 different sizes. I cut a bigger one, which is about this big, and it worked. And then I tried a little bit smaller one to see if that worked, and they both worked about the same. I kind of liked the one that was smaller, just because I didn't have to hold it up so high, and it wasn't, it was a little easier just to hold above the light. So we're already talking about air, and we talked about air in our last experiment. And today we're going to talk about something that can cause wind. So when you might have asked the question in the last experiment, can we feel air? And we can feel it when the wind blows. And so that's just the movement of the air. So, and why does the air move, and what causes it to move? So we're going to figure out how temperature affects the air. That's kind of going to be what the focus of our experiment is today. So cut out your spiral, and then at the top of it, you're going to just use a small piece of tape to tape your string. And we're going to get hypothesis. I'm going to move this over. Okay, you can see it. So get hypothesis from the students. What's going to happen when I hang my spiral over the light? Is the spiral going to move? Is it going to change? Is it going to shrink? Will it spin? What's going to happen? And then you can see that it wants to spin. Sometimes my breath wants to make it move, but it is spinning. So why does the spiral want to spin? What does it mean when it spins? What's causing it to spin? And it's the air that's moving. Why is the air moving? It's because there's heat. So what happens to air when it gets hot? So you talk about what happens to air molecules. Whenever we add heat, we're adding energy to the molecules. And so when the air molecules get hot, they're shaking around more, and they're kind of spreading out more. And so the area around the light bulb gets really energetic, and the molecules start to space out a bit. And so that makes the air lighter, because there's not, we talked about the atmospheric pressures when that gravity pulls all the molecules together. But when they kind of start to separate a little bit, it gets lighter. So that lighter air, we know that things that are lighter, that are less dense, they want to move up. And the heavier is going to come underneath. So that's our colder air. And Nicole Liam kind of has a diagram explanation of this. So the hot air molecules, they want to go up because they're lighter. They're farther apart, the air is less dense. And the cooler air is going to rush in underneath. And this kind of makes this cycle, this convection cycle. And so that's what it's doing. The air is moving around where this light bulb is. So the movement of the air is causing the our shape to spin, our spiral to spin. And so that's kind of what we're talking about. So when you think about, that's what a hot air balloon uses. That's why a hot air balloon floats. It heats up air inside the balloon. And so that hot air is less dense and wants to rise. And then the cooler air comes underneath, so it floats. So meteorologists can also study, temperature changes, and how that is going to create winds. If you're on the beach and you're on the sand, that area the sun heats up that sand really quickly, and it heats up the ocean less quickly. So the air on the beach is hot, and that's going to move out to where the water is. And then the air that's over the ocean is cooler, and that you'll feel that cool ocean breeze. So we can see the effects of the wind. We can see the leaves rustling. It's good for sailboats. That's what fills their sails. It can even cause tornadoes. So since the surface of the earth is not the same everywhere. Some parts are lower, some are in the shade, some parts are in the sun a lot. So we have parts of the earth that are heated unevenly. So there's some warmer parts and some cooler parts. So that causes air movement. The warm air wants to move away and the cool air wants to replace it. So that causes wind on the surface of our earth. So it's really cool to kind of start to get an understanding of what causes wind and learn more about our air. And so I think that's it for week 18 for Cycle 1. So I'll talk to you guys soon. Bye.